Me today. My name is Shelley Crosby, and I'm a senior scientist at Conservation Science Partners. I want to talk to you today about a process that my colleagues listed here and I have developed to make EcoDrought science more actionable. Ecological drought impacts are becoming a much bigger deal, not just here in the US, as is shown here, but globally. We wanted to craft a process where new EcoDrought science can be actionable in terms of leading to effective adaptation strategies. So this process begins with a decision-making context. It follows a conceptual framework, and it integrates stakeholders throughout. It leverages remotely sensed data from recent droughts, and it ultimately brings visualizations to the table so that understanding vulnerability can link to effective adaptation strategies. Our process focuses on EcoDrought drivers, impacts, visualization, and adaptation, or as we like to call it, the EcoDrought DIVA process. And it has 6 steps that integrate science inquiry, shown in yellow here, with stakeholder engagement, shown in green, throughout the process. It has these 6 steps that I want to walk you through each of them in a case study. So our process starts with the decision context. In this case, it was a drought planning process in the upper Missouri headwaters in southwestern Montana. For each Huck 8 level watershed, we identified a drought of interest from 2001 to 2005. We also held participatory workshops focused on ecosystem services, and we conducted semi-structured interviews to understand that drought impacts to forests are a priority concern. Step 2 in our process asks that we consider a holistic range of drivers. So we rely upon a conceptual framework, the Ecological Drought Framework shown here, which considers a broad range of drivers, including climatic, ecological, and landscape characteristics, and the consideration of both human and natural processes. We integrate stakeholder perceptions of important drivers of ecological impacts. And we also identified something in this process that really changed the course of our analysis, which was that stakeholders wanted to link ecological impacts directly to drought indices, such as some of these shown here. Step 3 includes creating or gathering data on ecological impacts. In our case, we calculated the trend in NDVI over the 5-year drought period. And the red pixels shown here are areas of very strong negative trends in forest health during that early 2000s drought. Step 3 also includes gathering data on drivers for the vulnerability model, which in our case included various drought indices and snowpack estimates, as well as ecological and landscape characteristics. And I just show you some of those here. Step 4 includes quantitative modeling, and in our case, we use a machine learning technique, boosted regression trees, to show the relative influence of each driver on the likelihood of ecological impacts to forests during the early 2000s drought. So here we're showing results for all 8 of those Huck 8 level watershed models together, and you can see that the drought indices shown in blue are generally the most important, but the landscape and ecological variables shown in kind of red and green also matter significantly. Step 5 focuses on visualizing EcoDrought vulnerability, which we do with these flower plots, where the longer flower petals are the most important variables in the model, and they are color-coded based on type. So we produce these flower plots for each of those Huck 8 level watersheds. The 6th and final step is to use a nuanced and place-based understanding of EcoDrought vulnerability to craft adaptation strategies that really address these key drivers. So for example, monitoring drought indices, thinning forest, utilizing beaver mimicry, or some other kind of strategy to keep water on the landscape longer. These are the kind of things we want to consider now that we have a vulnerability analysis for this region. So this step occurs via a participatory planning process, and this is what we're about to do next with our project in Montana. So overall, we want to introduce the EcoDrought DIVA process to you as a way to understand EcoDrought vulnerability and really proactively manage future EcoDrought impacts. Our process begins with the decision-making context. It follows a conceptual framework. it integrates stakeholders, and it leverages remotely sensed data from recent droughts. And finally, works to link that understanding of vulnerability to effective adaptation strategies on the ground. So many thanks, and please get in touch if you have any questions.